Hello and welcome to today's video. In today's video, we're going to be looking at some basic Newtonian mechanics, okay? Now, let us start. According to Newton's second law, he said that the net force, which is F net, is equal to the sum of all the forces acting on an object. Now, in this scenario, the net force here is going to be your force applied plus your force of friction. Okay? Now, notice that your force applied is acting in the positive x direction. And your force of friction or your kinetic friction is acting in the negative x direction. Okay, force is a vector, so it has both magnitude and direction. Now, let's talk about the concept of friction. According to experimental analysis, the force of friction Fk is directly proportional to the normal force. Now, on this object, there is a normal force acting upward. As you can see, and there is a weight force acting downward due to the force of gravity. And notice that there is a weight force acting downward, which is what? Mg. So your weight force is equal to mg, which is the mass times the acceleration due to gravity. Now, Fk is equal to what? Mu n. Okay, where mu is the coefficient of friction. So we can simply say that what? Mu is equal to what? Fk divided by n, your normal force. Now that we know that, it is very important for us to know that Fk equals mu n. That is, Fk equals the coefficient of friction times the normal force. Now, what is the normal force? So, according to Newton's law, the sum of all the forces in the y direction is equal to, what are the forces in the y direction? We have the normal force acting up, so it's going to be positive. Remember I said that that force is a vector, which means it has both magnitude and direction. So anything in the positive x direction is going to be positive, the force will be positive. Anything opposite that in the negative x direction, the force becomes negative. Anything in the negative y direction, because right here you have the negative y direction, so you can see anything that is in the positive y direction is going to be positive, and anything in the negative y direction will be negative. So the normal force here is going to be what? Is going to be positive. Notice that the normal force is due to Newton's third law. Now, the sum of all the forces in the y direction, let me come again. is equal to the normal force minus the weight force. This means that MA is equal to the normal force minus the weight force. But notice the acceleration in the y direction is what? Is 0. There is no acceleration up or down. We are only moving left and right. So therefore, what we're going to have is that is equal to the normal force minus the weight force. So 0 equals N. So what we have is that the normal force is equal to the weight force. So therefore, your normal force is equal to mg. Now, let us substitute mg into our Fk equals mu n, which is the coefficient of friction times the normal force. So therefore, Fk is going to be mu mg. That is mu what mg. So it means that mu, which is the coefficient of friction, is going to equal Fk, that's the force of friction, divided by mg. So there you have it. Now, let us say we are given an applied force of 50 newtons. Let's say we have an applied force of 50 newtons, and then we have Fk, that's frictional force, to be 25 newtons. Well, according to Newton's second law, your net force is going to, what is your net force? Is going to equal your force applied plus the force of friction. Now, since we know that friction is acting in the opposite direction, or it is opposing the motion and it is acting in the negative x direction, is going to be a negative. So that's Fa minus Fk. So what do we have? That's going to be 50 minus 25. So your net force is going to be 25 what? Newtons. What if you were not given friction? What if you weren't given Fk, but you were given mu k? You are given the coefficient of friction to equal. You are giving your coefficient of friction to equal 0.35. Now the question is that you should find your net force. So F net is going to equal, your force applied is 50 newtons minus, what is going to be your Fk? Your Fk is going to be mu k n, which is what? Mu k mg. So we know that the mass of this object, or the mass of the block, is 5 kilograms. So F net is going to equal 50 minus mu k is 0.35. The mass is 5, gravity is 9.8. So what do you have? You have F net is equal to 50 minus What is 0.35 times 5 times 9.8? Plug that into your calculator and let's see. That is 17.2. So what is going to be Fnet? Fnet is going to equal, what is 50 minus 17.2? That is going to give us 32.8 newtons. Now, what if we want to find the acceleration in the x direction? Since we know that the net force is going to be positive and is going to move in the positive x direction, how do we find the acceleration? Well, we know that the net force, Fnet, is equal to ma. Acceleration is a vector, which means it has both magnitude and direction. So our acceleration is going to therefore equal the net force acting on the system. If we have just one force acting on the system, then the acceleration is going to be just that force divided by the mass of the object. But since we have two forces, which is the force applied and the force of friction, your acceleration has to be the net force divided by the mass. So that's going to be acceleration. So you plug that in and you should get your answer. Thank you for watching.